Hello everybody, welcome to this video. We'll be solving the very first problem of Project Euler, which is to find the largest pan-digital prime that exists, which is under the length of 9 digits. So first we'll want to import math for our prime function. Then we'll want to define a variable called highest prime, which will be the answer. End up being the answer. Then we'll define all the numbers which we're going to be using. First we're going to write the isPrime function, which will determine if a number is a prime or not. So using this, we round up the square root of the number, because after going that far, it is pointless to search further. So if it has factors, return false, but ends up having no factors, it will return true. Then we'll be finding the permutations of 1, 2, 3, 4, 5, 6, 7, 8, 9. It's going to return it in a list format, so we have to convert it to one integer. So using this tiny function we can do that. Now we'll be using this function to find permutations. Which will take in a string. And this, but we don't really need it. So we're gonna need to access the highest prime variable. So this will be checking if we have gotten an answer. Now we'll be checking if it is prime and if it is above the current highest prime. Then if it is a prime and the new highest, we will define it as the newest highest prime. Then here it will do the permutations. So using this, we can it will successfully find permutations of the desired strings, and then this is recursive until it finds all the possibilities. Then we will iterate through n lengths. Oops. So now that we find all the n lengths and their highest primes, we will print out the highest prime. And then we get our answer, which, if we look back, is indeed correct. Thank you for watching my video, and I'll see you next time.